Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. What's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. I'm so excited that you're here with me tonight. We are here every Wednesday, like Dr. A said. So for those of you who have been with us for a few weeks, welcome back. For those of you who are new, welcome. We go through problems K through 12, pre-K through 12 really. And I usually try to make sure that I let you know what that problem is going to be addressing. So before we begin, I always like to start off with a little introduction. So if you could drop in the comments your name, your name will already be there, but where you're from and what test you're prepping for, that would be super helpful because it allows me to see what tests are in this room or what people are in this room and what tests you're prepping for so that I can kind of guide the rabbit trails that we go on tonight based on that. Also, drop in the comments your favorite holiday movie. My all-time favorite holiday movie is Elf, but I've recently really enjoyed Noel. If you haven't seen Noel, I'm not going to spoil it for you, but it is adorable and one of my favorite holiday movies as of late. So Elf and Noel are probably my top two. My husband's favorite is the Home Alone series. He absolutely loves the Home Alone series, so we've got that playing a lot too. So where are you from? What test are you prepping for? And what is your favorite holiday movie? Hey, Sophie, welcome. Hello, Jim, welcome. We're going to go ahead and get started right away today. So without further ado, as you're coming in, go ahead and introduce yourself to the group. And we're going to get started with our first problem. Now, as I'm going through these problems, please, please, please don't hesitate to ask questions as I'm going. I can read the comments and solve the problem at the same time. So please comment and let me know if you have any questions. And also, if there's a specific area that you want to see me address in upcoming Wednesday sessions, please let me know. So if you want to see more geometry, more linear functions, more probability, more Trig, just let me know in the comments. That helps me build the upcoming Wednesday problem sets. In fact, I had quite a few people last week say they wanted probability and geometry. So we've got a few geometry problems and a few probability problems tonight. So problem number 1 is a geometry problem, and it's written for a K through 6 exam. However, I'm going to show you how if we change just 1 or 2 words, it would immediately become a Praxis Core, GK Math, middle school, high school problem very quickly. So we're gonna kind of show both. Hey, Stephanie, good to see you. Good to see you here. All right, below is an image of a rectangular field. If Sophia runs from W to X to Y to Z, how far did Sophia run? Many times when people see problems like this, they immediately are just going to find the perimeter of this shape, or they're going to find the area of this shape, because those are the 2 formulas that we know. So a lot of times people are going to jump right to finding the perimeter or right to finding the area of this shape. However, we really need to understand what this problem is asking of us. This problem is saying, I apologize for the scratching in the background. My Great Dane is trying to get comfortable right now. They are saying that we're trying to go from W to X to Y to Z. So we're running, which means we're finding a linear measurement. We're not finding the area of something. And we are not finding the entire perimeter of this shape because she doesn't go back to W. We're starting at W and running to X, Y, and Z, and then we're not coming back to W. So really, we are just doing those 3 sides. And because we know this is a rectangle, we know that this side is 310 and this side is 75, but this 310 is not necessary because we're not running that distance. So all we have to do here is do 310 plus 75 plus 75. And if this was a K through 6 exam, we would not have a calculator. So 5 plus 5 is 10. 7 plus 7 is 14, 15, 16. 3 plus 1 is 4. So the answer to this problem would be B. Hey, Hope, good to see you. Hi, James. You're from New Mexico and the Grinch who stole Christmas. Okay, which animated version is it? Is it the old school animated version, like the 30-minute one, or the new hour-and-a-half one that is like on Amazon Prime? I love the new one, I have to say. I didn't like it at first. Now, if we were to change this problem to make it more of a middle school, high school, 6 through 12 problem, here's what we would say. Let's go ahead and copy this and paste it and change it up into a middle school, high school problem. So we just solved it the way it's written. But if this were to be rewritten, below is an image of a rectangular field. If Sophia runs from W to X to Z to Y, how far did Sophia run? All I did was flip those 2 variables, and now we have a middle school and high school problem. Why? Because the route she's taking now is W to X to Z to Y. What dimensions do we need now? Well, we already know this is 75. So I would be doing 75 plus 75, which is 150. But I don't have this measurement right here. Well, what formula can I use, my middle school and high school people, to find that? I know this is a rectangle, which means I know these are 90-degree angles, which means I can use the Pythagorean theorem to solve for that missing side. Pythagorean theorem only works on those right triangles, so I can do a squared plus B squared equals C squared. And that means I can identify this as A, this is B, or vice versa. So I have 75 squared plus 310 squared equals C squared. How do I know that this is C? It doesn't matter if this is A or if this is B. Good job, Stephanie. How do I know that's C? Because C is always going to be your hypotenuse, which is across from your 90-degree angle. So C is always going to be your hypotenuse, which is across from that 90-degree angle. Because I'm taking a middle school or high school test, I'm going to go ahead and a calculator. So 75 times 75 is 5,625. 310 times 310 is 96,100 equals C squared. Add those together, 101,725 equals C squared. Now I need to square root that, and I get C is approximately 319 feet if we were to round to the nearest foot. Now I can go ahead and add my green dimensions because we're going from W to X to Z to Y. So I can add that 150 plus 319. We're not going to have the answers there because I just decided to do this on a whim. So 150 plus 319 would give us that answer, 469. So that's how an elementary problem, a problem that was written for K6, could very quickly turn into a problem for our 6 through 12 people. And that's why I like to see what tests you're prepping for. Because if I have a room full of elementary people, I'm not going to go ahead and change that. The animated version of the 30-minute one. You know what? That's just a classic. That's one that everybody loves. All right, let's go ahead and keep going. Problem 2, another geometry problem. Jonathan wants to build a frame for a painting that he created. He wants to make the frame a 3-inch wood frame all the way around the painting. If his painting is 4 feet by 6 feet and wood costs $2.50 per square inch, how much will the frame cost? On these Wednesday night sessions, I like to try to pull problems that are going to be appropriate for the gamut. So while you may not see this problem on a K6 test or a pre-K3 test, you most certainly need to understand the concepts behind it. So let's go ahead and break this problem down. He wants to build a frame for a painting he created. So the first thing I do when I'm looking at a geometry problem is I draw it. So I've got a painting, and we're going to say it's a mountain painting. And then I'm creating a frame around it, a wood frame that's 3 inches. So there's my frame. It's actually a pretty good picture. And we know that it's a 3-inch wood frame. So we know that this distance is 3 inches. This distance is 3 inches, and all the way around it's going to be 3 inches. If his painting is 4 feet by 6 feet, so I know that the painting itself is 4 by 6. And wood costs $2.50 per square inch. How much will the frame cost? We have to make sure that we have a plan for this problem. So the first thing I need to do is figure out the area of my wood only. I have to figure out the area of the frame, because I'm not paying for the area of the painting. I'm only paying for the area of the frame. So I need to figure out that area of the frame. Then I need to figure out my cost. I need to figure out the area of my frame, and then I need to figure out my cost. So how am I going to figure out the area of that frame? Well, I can do it 2 different ways. I can find the area of that whole thing, of that whole picture. I lost connection with my iPad. That's why I switched the view. All right, here we go. So I can find the entire area and then subtract that painting, or I can do little rectangles. Little rectangles is my favorite way to solve it, but that's just me. But what dimensions do we have? We have feet and we have inches. So I have to change or convert my feet into inches because the cost is per square inch. So I need to shift my painting dimensions into inches first. So here's what I'm going to do. 4 is actually how many inches? 4 feet equals how many inches? 4 feet equals 48 inches. If you take the GK, you get a reference sheet that tells you this. Everybody else pretty much needs to know basic conversions. And then 6 feet is going to equal 72 inches because 6 times 12 is 72. 1 foot has 12 inches. So 4 is actually going to be 48 and 6 is actually going to be 72. So now I can either find the big rectangle or I can find little rectangles. I'm going to go ahead and find little rectangles. So I'm going to go ahead and cut this frame into 4 little rectangles. So I have 2 blue rectangles, and then I'm going to have 2 red rectangles, and if I add those all together, it'll give me the area of my frame. So what are the dimensions of my blue rectangles? Well, the length is 48 and the width is 3. So 48 times 3, I'm going to use my calculator, is 144. So the area of this rectangle is going to be 144, which means the area of this rectangle is also going to be 144 square inches. Now, this is where people get tripped up. If I'm trying to find the area of the red rectangle, how am I going to do that? Well, my width is still 3. Like this is still 3. So I'm doing 3 times something, but what is this whole length? It's 72 plus 3 right here, plus 3 right here. So it's 72 plus 3 plus 3, not 72 plus 3. A lot of people make the mistake on these problems and they just add 3 one time. They don't add it on both ends. Let me show you that again. We have 72 right here, and then we have 3 right here, and we have 3 right here. So 72 plus 3 plus 3 is 78. So we're actually doing 3 times 78, not 72, not 75, 78. So 3 times 78 is 234. So the area of that little red rectangle is going to be 234, 234. Now I can add green plus red, and I'm going to have the area of that entire frame. So 144 plus 144 plus 234 plus 234. I don't know why that keeps happening. If someone's an iPad expert and knows why my iPad constantly disconnects from my Mac, please let me know, because it happens like once a session and I don't really understand why. So we add all of those up. 144 plus 144 plus 234 plus 234. So when we add all of those up, we get 144, 144, 234, 234. We get 756. That's not our answer, though. 756 is just the area of the frame. We just found that. Inches squared. Now I need to find the cost. Well, the cost is just $2.50 per square inch. Per square inch means every square inch is $2.50. So $2.50 plus $2.50, 756 times, that's called multiplication. So 756 times $2.50, I can multiply that and get my answer of $1,890. Does that make sense? If you have questions while I'm solving these problems, please don't hesitate to drop your questions in the comment box. Also, for those of you who missed it, please make sure that if you have areas that you want me to solve next week, well, we're actually not here next week, but in future Wednesday sessions, like you're like, I really want to see you solve some more function problems or linear problems or triangle problems or probability problems. Drop that comment box below too, because that really helps me guide our direction and build problems out for every Wednesday. So let's go ahead and keep going to problem number 3. The table below shows Jason's weekly math test scores from a 5-week time frame. If he scored a 93 on his math test for week 6, what will the change from the 5-week mean and the 6-week mean be? All right, that's an interesting question. Hey, Jim, the next session will be in 2 weeks. So we're going to take a break next week. That's a great question. We're going to take a break next week for the holidays, and then we will come back on the 29th. So we will not have session on the 22nd, but we will have session on the 29th and every Wednesday after that. So that's the 1 week that we're going to take off. Christmas falls on a Saturday. New Year's falls on a Saturday. Some of the other holidays fall in between that. So we're just going to take 1 week off and then join back on the 29th. All right. So the table below shows his weekly math tests for 5 weeks. And they're asking if he scored 93 on his math test for week 6, what is the change going to be from the 5-week mean and the 6-week mean? What does change mean in this problem? That's really what we need to figure out first. What does change mean in this problem? The change means the difference. So this vocabulary right here is critical. This means the difference. So what is the change? Like if my plant is 5 inches tall on week 1, and then in week 2, it's 8 inches tall, what is the change from week 1 to week 2? We would subtract, and it would be 3 inches. So if you're not sure what a vocabulary word means in the context of a problem, try to think of your own problem, a very simple example. I like to do that a lot, and then it'll help you kind of process what that vocabulary word means. So this means the difference. So the difference between what? We need to subtract the 5-week mean and the 6-week mean. So that means we need to find the 5-week mean and the 6-week mean and then solve for that. When I'm tutoring one-on-one clients, the biggest problem is not the actual mathematics, it's the interpretation of what the problem means. So in fact, I presented this problem to one of my younger clients who's in middle school. This is a very classic middle school problem. She knows how to find mean. She knows how to find all of this stuff. She could not process what the problem was asking, because often that's the most difficult part of all of this, is processing what this means. So we need to find the 5-week mean. We need to find the 6-week mean and then subtract. What is mean? Well, mean is a variable of central tendency, and I think of it as being very mean because it makes us do a lot of work. So mode is like the middle of the data. So easy. Median, no, mode is not the middle of the data. Median is the middle of the data. Mode is the one that occurs the most, but then mean is the one that makes us do a bunch of work. It's also the average. They mean the same thing. So I'm going to add all the test scores up and then divide by the number of data points I have. So I'm going to add all of these up. And then I'm going to divide by 5 because there's 1, 2, 3, 4, 5 data points. So I can do this by hand or I can do this by calculator. I'm personally going to choose to do this by calculator just so we don't make any careless errors, but you have to know your test. You have to know if you get a calculator or not. So 85 plus 71 plus 94 plus 67 plus 88 equals 405 divided by 5 equals 81. So that is the 5-week mean. 5-week mean equals 81. Now, if he scored a 93 on his math test for week 6, so let's go ahead and add a box. He scored a 93. Now I need to add all of those up plus that 93. So 85 plus 71 plus 94 plus 67 plus 88 plus 93 is going to equal 498. And then divide that by 5? No, by 6. Because now we have 6 weeks, not 5 weeks. So divide that by 6, and we get 83. So the 6-week mean is 83. So what happened from 5 weeks to 6 weeks? We increased by 2. Does that make sense? Stephanie mentioned that she has a song like row, row, row your boat. Mode, mode, mode is the most. Average is the mean. Median, median, median is the middle. And that's my song. That's great. I love it. Thanks for sharing, Stephanie. That kind of stuff is what's going to stick in your head when you're sitting at the test trying to figure out what you're doing. I like to think of it as mode sounds like most. Median, I like to think of like car, like the road, the median is the middle of the road. And then mean is just mean, and it's just your average. Like it makes you do a lot of work. All right, let's move on to problem 4. Now, another measure of central tendency problem, because data and statistics is often where people struggle. So the table below shows the bowling score of 5 students on the local high school bowling team. The score of 80 seems to be an outlier. Which measure of central tendency changes the most by dropping the 80 from the data set? Well, we would have to figure out each of the central measures of tendency and then drop that 80 and then figure them out again. So I'm actually going to put them in order because putting them in order helps us figure out the mode and the median really, really quickly. So if I list these in order, 80, 122, 122, 135, 145, I immediately can see that my mode is not going to change. So I'm going to cross that answer off immediately. Why is my mode not going to change? Well, my mode is my most. And if I keep my data set the way it is, the mode is going to be 122 because it's showing up the most times. Mode is not the highest. It's the one that shows up the most times. Well, if I get rid of the 80, the mode is still the same. So that's not changing. So mode is out. That one immediately goes away. Now, with the 80, without the 80. If I have the 80, what is my median? Median is the middle. Well, 122 is in the middle, right? So with the 80, my median is 122. Without the 80, let's erase that 80, what would my median be? Well, I would cross these off, And then I would have to find what is in the middle of 122 and 135. And I can do that by adding them together and then dividing by 2. So 122 plus 135 divided by 2 is going to give me what's between the two of them, which is 128.5. That's only a change of about 6. So let's keep going. I'm going to find my range next because my range is just the smallest and the highest subtracted. So let's go ahead and find that. So we have 80 here. My range with the 80 is going to be 145 minus 80, which equals 65. My range without the 80 is going to be 145 minus 122 instead, because now 122 is my smallest data point, which is 23. All right, so let's go ahead and keep going. Now I know it's not median. Now, because we're looking for the one that's changing the most. And it's not median because median only changed by 6.5, but range changed by way more than 6.5. I don't need to know what, I just know it's bigger. So now I'm going to cross off median as well. Now we have to find the mean. So let's find the mean with the 80 and without the 80. So to find that mean, we're going to add all of these up and then divide by 5. So 80 plus 122 plus 122 plus 135 plus 145 equals 604 divided by 5 gives us 120.8. Now we're going to do it without the 80. So I'm going to do 122 plus 122 plus 135 plus 145. So I'm going to add these up and then divide by 4 instead, because now instead of 5 data points, I only have 4 data points because I got rid of the 80. 524 divided by 4 gives me 131, and that difference is not very big. It's only about 10 or 11. So the range definitely changes the most. Now, if you were in a time crunch on this problem and you needed to figure that out pretty quickly, you could recognize that because 80 is an outlier, it's going to drastically change your range, because if the 80 is an outlier, whether it's on the high end or the low end, that's going to be where the range comes from. And if we get rid of that, it's going to drastically pull the data either to the right or to the left. And so it's going to drastically change what that range is going to look like. So if I was on a time crunch, I had 1 minute to answer this question and 3 more, I would pick immediately, just because I know that because it's an outlier, it's going to change it drastically. But if I have the time to solve it, I'm definitely going to, just to make sure. All right. Moving on to some algebraic thinking questions. So if Z, I'm going to zoom in. This is a lot of space there. If Z equals 3.2, what is the value of 3Z plus 5 square roots of Z plus 5.8? This is purely just algebraic thinking, the ability to manipulate numbers and know our order of operations. So let's go ahead and solve this problem. I'm first going to write my original problem just the way it is. 3Z plus 5 square root of Z plus 5.8. Now, I know that this is going to extend all the way across because they included this parenthesis. Had they not included the parenthesis, if it looked like this, and I ran out of space, If it looked something like that, then we would know that the square root is not extending all the way to that 5.8. But because there's those parentheses around it, we know it's extending. So let's go ahead and solve this problem. I'm just going to take this 3.2 and plug it in for z wherever there's a z and solve it. 3 times 3.2 plus 5 square root of 3.2 plus 5.8. 3 times 3.2 is 9.6. How do I know it's 9.6? Because when I multiply, I got 96. But because there's only one decimal place in my original problem, I'm going to move my decimal place only one spot. So it's 9.6 plus 5 square roots of 5.8 plus 3.2, which is 16. What is the square root of 16? 4. You're absolutely right. So 9.6 plus 5 times 4, 9.6 plus 20, and we get 29.6. Interesting. The correct answer is not there. Gotta love when that happens. All right, I'm just going to erase this. And we're just going to say the answer is 9.6, unless I made an error somewhere, which is entirely possible, y'all. I can absolutely make an error, especially with this pregnancy brain that I've got going on. Let's be real. So 3 times 3.2 is definitely 9.6. So I'm going to go through and check my work because that's what a good mathematician does. And then 3.2 plus 5.8. There's my error. Thanks, Stephanie. 5 plus 3 is not 16. 5 times 3 is 16. This 5 times 3 is 16, but 5 plus 3 is definitely not 16. So we're going to go ahead and erase the 16. 5 plus 3 is 9. 8 plus 1 is 9. So square root of 9. The square root of 9 is 3. 5 times 3 is 15. And 15 plus 9.6 is 24.6. I should trust myself a little bit more that these answer choices are correct. B is the answer. So I actually, thank you so much, Stephanie. I'm actually very thankful that that happened. Here's why. Because I need you to see that, number one, I make errors too. And number two, that would be how you would go back and check your work. So I went back and confirmed that this was correct. I should have put a plus sign here so that my brain remembered that I was adding and not subtracting. 8 plus 2 is 10, but 5 plus 3 is 8, plus an extra 1 is 9, not 16. 5 times 3 is 15, but it's 9. So 24.6 is our answer. All right, let's do another algebraic thinking question. So the sum of 2 consecutive integers is 17. What is the value of the smaller integer squared? These kinds of problems trip people up a lot of times because it's very wordy and our brain doesn't associate it like a math problem like problem number 5 was. So what does the sum mean? The sum means the answer to an addition problem. Answer to an addition problem of 2 consecutive back-to-back integers, numbers really, is 17. So something plus something equals 17, and it's not 10 plus 7 because 10 plus 7, they are not consecutive. Consecutive would be like 1 and 2, 21 and 22, 88 and 89, all consecutive numbers. Now, this might be something that you can just think in your brain. You might be able to realize that 8 plus 9 equals 17, and those are consecutive integers, and then be able to solve this. But not everybody can visualize that, and not every problem is this simple. So how would you solve this problem if it wasn't that simple? Well, good question. If we identified a variable, this is a very algebra way to solve it. If we identify x as the smallest integer, then what would the next integer be? The next integer, I could call it y, but then that's not helpful. X plus y equals 17. I would have two variables, and that wouldn't be helpful. So I could do x plus 1 equals the next integer, or the larger integer. Why would x plus 1 be the larger integer? Because they're back to back. So if 8 is the smallest integer, 8 plus 1 is going to be the next largest integer. So now I can just set that equal to 17. X plus 1 equals 17, because the sum of two consecutive integers is 17. Now I have 2x plus 1 equals 17. Subtract 1 from both sides. 2x equals 16. Divide by 2, x equals 8, which means the larger integer is 9. Now, like I said, some of us would have been able to visualize this and know it right off the top of our head, but not all of these problems are this simple. Sometimes they say the sum of two consecutive odd integers, and then it wouldn't be x and x plus 1, it would be x and x plus 2. Because if they're both odd numbers, then it would be like 9 and 11, or 11 and 13, or 13 and 15. So all that said, what is the value of the smaller integer squared? 8 squared is 64, but you notice that 8 is here because some people are going to see value of the smaller integer and choose that answer. So don't take this problem and know how to solve it and then get the wrong answer just because we were rushing and not paying attention to what the question is actually asking. All right, problem number 7. Look at the following equation. What is the value of x? This is most definitely a 6 through 12 problem. And here's why. Because we have to have a strong understanding of bases and exponents to be able to solve this. So how would we go about finding the value of x in this problem? The easiest way to do it is to get our bases to be the same. Because if the base is the same, then the exponents are going to be equal to each other. Let me give you an example. If I have 3 to the 4th power equals 3 to the x plus 1 power, well, that's kind of obvious. X would be 3. Why? Because you know that 3 to the 4th power has to equal 3 to the 4th power for it to be equivalent. So if the base is the same, I can just set my exponents equal to each other, subtract 1 from both sides, and x equals 3. So how in the world can I make these bases the same? 4 squared is 16. 4 cubed is 4 times 4 is 16 times 4 is 64. That's not helpful. So what base could we use? We can absolutely use the base of 2. So 4, I can substitute 4 out. So I can take this 4 out and substitute it for 2 squared. Is 2 squared the same thing as 4? Yes, absolutely. So all I'm doing is substituting it out. I'm taking the 4 out and replacing it with 2 squared times 3x plus 2. Now I'm going to replace the 32 with 2 to the what power? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th power. And then don't forget this 5, because this is not just 32. This is 32 to the 5th power. So a common error here is going to be that people are just going to do 2 to the 5th power and call it a day. But 2 to the 5th power is replacing the 32, but then we still have this 5 as an exponent. Now my bases are the same, so I can just set my exponents equal to each other. 2 times 3x plus 2 equals 5 times 5 is 25. Solve for x. So I'm going to distribute this right here. 6x plus 4 equals 25. Subtract 4 from both sides. 6x equals 21. Divide side by 6. And I get x equals 3.5. Excellent job. All right, let's keep on going. I'm actually going to skip a couple of these problems because I want to get to our probability problems, because I know a couple of people specifically requested probability problems. So let's go ahead and do this problem. Jason has a drawer full of markers. He has 15 blue markers, 7 green markers, and 21 red markers. What is the probability that he picks a blue marker, holds on to it, and then pulls out a red marker? So here's what we need to understand about probability. Probability is the number of outcomes we want over the total number of options that we have. So probability equals the number of outcomes that we want divided by the total number of outcomes that we have. So let's talk about this. What is the probability he picks a blue marker, period? Let's not think about this yet. What is the probability that he picks a blue marker? Well, what is our desire? Our desire is to have a blue marker, which is 15. So if our desire is to have a blue marker over our total number of markers, then what are we looking at there? What is the total number of markers? Well, 15 plus 7 plus 21. 15 plus 7 plus 21 is 43. So the probability that he's going to pick a blue marker is going to be 15 out of 43. Hey, Hope, I see your question, and I will come back to that question in a minute because it's not related to this problem number 10. So then it says he holds on to that marker and then pulls out a red marker. Well, if we're doing combined probability like this, we are going to multiply probability number 1 by probability number 2 to get that combined probability of blue marker and a red marker. So he's holding on to that marker. What is so significant about this piece of information right here? What's the significance there? The significance there is that there's not that marker in the drawer anymore. So rather than having 43 markers in the drawer, we now have 42 markers in the drawer. Now, what's happening? We're pulling out a red marker. The red marker, there are 21 red markers. That's my desire for the second pull out of the drawer. And now I'm going to multiply those two together to get the probability that he's going to pick blue, then red. 15 times 21 is 315. 43 times 42 is 1,806, and we see that that is not an answer choice because that is not the most simplified version of that fraction. Now, we could sit and divide and figure out what that fraction is going to be. The thing that I notice is that this fraction is exactly half. 21 is half of 42, so I can actually replace this with 1 over 2 because those are equivalent fractions. And that's a whole nother ball game other than probability. So if you need help with equivalent fractions, comment below. We can talk about that on another Wednesday. But those are equivalent fractions. So that's going to make my multiplication a lot easier. 15 times 1 is 15. 43 times 2 is 86. So my answer is going to be 15 over 86. Could I use simple division to simplify this? Absolutely. I could do 315 divided by 3 and 1,806 divided by 3. And then I could keep simplifying that until it got down to 15 over 86. But like I said, I immediately noticed that that was 1/2. So that's where I went ahead and simplified that. But let's go ahead and look at a different example of the same problem. Jason still has a drawer full of markers. He has 15 blue, 7 green, and 21 red. Same exact numbers. Different question. How many markers would he have to pull out to be guaranteed to have 2 blue markers in his hand? Now, not could. This is not a could. How many markers could he pull out? He could close his eyes, pull 2 markers out, and he could have 2 blue markers. Is that a high probability? Not really, unless he knows exactly where these markers are sitting. So in order to be guaranteed to have 2 blue markers, he would have to pull out at least, and I'm actually going to give you the answer and then kind of work backwards. He would have to pull out 30 markers. Why? Because the possibility is there for him to pull out all of the red and all of the green markers. Well, what is 21 plus 7? 21 plus 7 is 28. Is it possible for him to pull out every red and every green marker before he picks a blue marker? It's possible. Is it probable? No, but we're not looking for the most probable answer. We're looking for how many would he have to pull out to be 100% guaranteed to have 2 blue markers in his hand. So now we've pulled out all the red markers, all the green markers, and then 2 blue markers are left. Well, 15 blue markers are left, but now I'm guaranteed to pull those 2 blue markers. So I have to exhaust all of my other options first and then get to my blue markers, which is 30. Does that make sense? All right, we're going to stop there for tonight. I have a couple more problems that we will address next time. So what I want to tell you is happy holidays, because we're not going to see each other until the 29th. So whatever holiday you celebrate in your home with your friends and or family, happy holidays. I will miss you all. Comment in the comment box below and let me know what kind of content you want to see on the 29th. What kind of problems do you want me to solve for you? Because this Wednesday night math session is, it's not for me. I enjoy it, but this is for you to feel prepared for your upcoming exam. So to answer your question, Hope, range is absolutely not a measure of central tendency. I apologize if I lumped it all together with the mean, median, and mode. Mean, median, and mode are measures of central tendency. Range is a measure of the spread. You're absolutely right. Thankfully, they're not going to quiz you on the definitions of those, so you don't have to worry about that. But yes, you are absolutely right. The question should have been worded a little bit differently, and I will absolutely change that for the future. So I'm going to turn it back over to Dr. A. He has a special code for you. Are we going to do Praxis Core for elementary school? I'm not so sure what your question is. The questions that we go over on Wednesdays usually address K through 12, but it's just an hour. So to be able to, we don't do specialized sessions just for one. All of our Wednesday night math sessions are for a range. So usually, and hopefully you get something out of it. You are welcome. Are these saved for you to review again on your own? I do think Dr. A saves them on our Facebook page. And we're here every Wednesday, so you can join us again on the 20th. And happy holidays to you as well. All right, I'm going to turn it back over to Dr. A, but I will be around in the comment box. So if you have any questions, let me know. And if you want a specific topic to be addressed on the 29th, let me know that as well. Otherwise, I will see you guys on the 29th. Thank you so much for joining me.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.